Hello? Hello? Yeah. Welcome everyone. So it's the second talk of today, Data Lake Entanglement. And with us is Geert Jongen. He's an architect at Van der Lande. We had a previous talk with Van der Lande as well, so it's 2 in a row for this room.
Only two.
Only 2. it will be the tops of today, but anyway, it's a good stat. Yeah, take us away. I'm curious to hear more.
Thanks. So, welcome everyone. Nice to see you all here, even with the rescheduling. I think it's nice that you guys found me. So, yeah, today I would like to share a bit about data lake entanglement and data mesh. So basically, yeah, we've been on quite a journey within Van der Lande. I want to share 2 bits of it. One being how did we end up where we ended up right now, and the second part will be some of the key feature I want to be to share a bit about. I think interesting concepts or things that that you can do. So to start, my name's Geert. I'm the architect. Studied here in Eindhoven, very close by. Did some consulting, Accenture, Pippel. I see some faces over there. And basically now at Van der Lande system architect for our data platform. For those of you, I guess, for those who attend the previous talk, you also know what Van der Lande is, but very briefly, we're a major company located in Veghel, which is actually quite close by here in the neighborhood. We have a large campus over there, thousands of employees, a factory, and our innovation center. And basically, if you know us, yeah, we were a family-owned business. Now we're part of Toyota. Turnover is around 2 billion, and basically, I guess most people know us from Schiphol, the belt systems, your suitcases and everything. But we also are big in parcels, so the DHLs, that type of business, and warehousing. So when I say data platform, then it's also good to set some ideas on what is a data platform. In our case, it's basically our centralized data platform within Van der Lande that's handling all the data that is internally focused. So we're ingesting basically from a lot of source systems data into our data platform. Then we have something we call it an AT layer. That's sort of a staging where basically all of this data is made available to data engineers, to BI specialists, AI, all of that. And then we have multiple ways that you can interact with the data. Most importantly, data products. That's where the data mesh concept comes in. But we also have labs and just jobs, basically just pushing data from one place to the other. And then there's consumers on the end side, which could be anything. So yes, we have a lot of dashboards for different places. We also have a lot of people doing analysis directly. But AI use cases are nowadays coming up, so where agents are pulling our data in to do some query lookup or to interact with it. So yeah, there's a huge variety in the types of consumers we have. Finally, some statistics that also you can see a bit of the scale. We have hundreds of data products now running on the data platform, segregated in 10 domains. So that's basically finance, supply, all of these company-wide groups. We also service some partner companies which are part of Toyota but not part of Van der Lande, which also need data, of course, or access to it. Our department's around 80 people nowadays working with data, so it's data engineers, but it's also data governance, data modeling, basically everything you can put the word data in front of we have in those teams. And we service now thousands of users directly or indirectly through these data products. So how did we end up here? Well, first of all, we started with an EDW, Enterprise Data Warehouse, and this data warehouse was basically the original starting point of Van der Lande. It had been the central source of truth, which was in that time very important. We used some data vault there. It was a Microsoft stack, so it was it was basically one system doing a lot of things. I think what really are important characteristics there is it was a technical team managing this EDW. It went through a number of upgrades where every time you said, well, let's take this, let's rebuild it in this new technology or in this new way. And then purely from a technical perspective, you made sure that with the same input you got the same output. So that's what we call the lift and shift stuff. And in the end, a lot of knowledge was lost. There were jobs running already for 5, 8, 10 years. Highly stable, very robust, but no one knew anymore why certain things were happening over there, or why did we exclude this business unit from that line, or very detailed questions. But of course, over time, they become really important. So how does this show up? Well, what I said, why are we doing things? That was getting increasingly hard to find out. And that resulted in two things. Fear of change. The team managing this EDW was really, it was hard to start changing stuff, because as soon as you introduced a new column or you changed the filter, it was very hard to predict what would actually happen after all of these jobs had run and whether every dashboard would still show the correct number. Scaling becomes hard, right? You don't want to, you're already busy maintaining what you have, and you don't want it. And then of course, and that's more a hidden feature, you introduce shadow IT. You really motivate your people to find routes outside of it, because you still have the questions you have, and you still have the daily business needs you you want to have met. So that was just happening. So basically that required a rethink. That was around 21, 22, and that really made data a central topic again, where we say, okay, let's make it a corporate asset. Let's tear down these silos that are existing between different teams who all have found their own way to the data and have made their own Excels that are extremely complicated and working, but there's no sharing, right? There's no agreement between it. That's where we introduced data mesh. I'll not go into a lot of it, but the most important topics, I think, are the data product thinking. You really put the data product central in your thinking, and you wanna you wanna make sure that if it's a product, you need to sell it, you need to market it, you need to understand what it is you're delivering to someone and why would they be willing to use it. So I think those are really good questions to ask yourself. And really important, we really spend time in a modeling team to get an enterprise architecture available, so that very simple things like a project could be aligned across all of these businesses. Our sales team had a completely different concept of project than our project execution team, who were actually delivering projects. They would not map, right? We would sell one, but actually we would deliver 3. And you need to be able how this all ties into together. So we created this new platform. We started out with Databricks also as basically our baseline for it with PySpark. We had domains who were starting to own their data, so we knew exactly this data product, we go to finance, and for this one we need to talk to supply chain. And we indeed saw that the speed was going up, so we were delivering faster and faster new data products, and we could make clear who was owning the data product and what they were doing with it. But of course, once you change it, you solve a few issues, you raise new ones, right? So what was still an important things we noticed is that even though we now knew exactly which data source we were consuming, and we would have some agreement on, we know when updates are running, we know when patches are being done, still it just broke. This example I put there, I think is still reality. There's just a patch being run, it shouldn't do anything, but then of course it does something. So that was still there. Also with these domains, we have multiple teams who are doing their own thing, and that needs to be kept together. That's really important. And I think the third and the fourth one are really people create their own data products, and we were focusing on making that easy with templating and with CI/CD pipelines and with all sorts of agreements. But if it's really easy, then sometimes just creating new data products becomes the default, which means that we had a lot of growth of data products that were just slightly different than other data products, which was documented, but still, you're still creating new baggage. You're still over, you get too many of them. Because then the question becomes, which one should I use for this case? And then, that's a challenge. And that meant also that the lead time was slowly increasing again, because we had to check if it exists again or not, and we had to look at our enterprise model. So that's part of the challenges. And then basically we went to this current setup. I think the most important change we made over the last 2 years was switching to Unity Catalog. So introducing a catalog is really a huge change. Previously we would be working with mounts, which basically meant you are reading from some sort of file storage, and of course you had delta tables already and things like that. But now with the Unity catalog, you really are just talking tables to tables or tables to views, and you lose a lot of that complexity. So, to summarize, I think you've now seen a bit of the journey where we are and the things we're tackling, and now I would like to explain a bit about decoupling and the concept itself, and then I'll dive into the different ways that we were doing that. So before, just apart from our journey, I think the key lessons are change is constant. That's an open door, but it's really true. It's not just your business requirements that are changing that need adjustment. We have new business units, we have new products, that's all changing. You also have Databricks itself constantly pushing updates, new features like Unity Catalog, but also a lot of small ones that have a big impact. And you really need to start thinking about, we should be able to replace anything at any time, basically, and try to achieve that goal to make sure that that we can stabilize. So how does it work in practice in our case? So I'll touch upon these 3 different topics. So teams and governance, really about how do we organize governance, working with multiple teams, making sure we can support that. Data contracts, so how do you keep track of data as it moves through the pipeline, and you can still change schemas or data definitions and all of that. And finally, in the runtime and delivery, how do you make sure that in practice, when things are running, one thing doesn't take down the whole set. So when we're talking about the teams and governance decoupling, then domains own their data products. I think that's a key concept, and it's also important that they then own the code with it, and that they all get their own repositories, for example. So this was really a key to make sure that every team can just push their own updates to their own data product, not having to deal with others also sharing code in that repository. And also you need your own backlogs in terms of agile or things to with team planning to make sure that you can work independently. We're organized as a hub and spoke model, so that means that there's a central platform team doing all of these templating, all of central tasks, but then this data, the data building, the data product ownership and all of that should happen in these decentralized spokes that all agree on the same rule set with the center, but then can apply them with their own needs and pace. Another important fact is our shared library, and I'll share an example after this. So you really want to have some pieces of code that are shared with these spokes so that you can just install the library and work with it. It has to do with code. You don't want to have every team reinvent a merge statement or things like that. But it's also really to do with practices, setting certain configurations and all of that. first of all, it aligns them, so it makes sure that every spoke has the same things enabled and disabled, but it also allows you to change centrally and then make sure that these changes go everywhere instead of having to go into every different data product and changing these settings, for example. Same for CI/CD, make sure that the same pipeline is used by everyone. Again, we have a template CI/CD centralized where we can do changes, introduce steps, remove steps, and then the actual pipelines deploying each data product are just taking the code from there. So that again, if we say, okay, we're going to introduce a new step to do a certain check or to require something, again, we can do it in one place and it will go to all the spokes directly. In governance standards, we do the same thing. So central governance is looking at the big picture. What standards do we need to adhere to? What are important regulations, things like that. Most of them are solved with policies or tags or classifications. Again, agree on the rules centrally and then make sure everyone can apply them decentralized on their own data product in their own terms. So to give you an example, this is just a fake example, but it shows the way it works. So we have a mesh utils function centralized. In this case, it's a write function, so that's really an important function, right? You want to have standardizations there, not necessarily because of the complexity of the code, because this is pretty standard, but mostly because of the variations you can have in terms of options and things like that. And then in the data product itself, you just import it and you use it. So it becomes really a scalable way to keep track of how we are writing and what we're doing. Similar with tagging. So this is more a Databricks feature, but typically these come available in other in the open source as well with a delay. So you create a policy. So that's basically just something that you create centrally. That's the team doing it. So in this case, we're saying if a table is tagged as a region table, apply this policy, which is basically filtering out rows. So if you're from Europe, you can see European rows, and US, you can see the US rows. That's a central policy that's handled by one team. Then the decentral team can just apply these tags. So they know if I tag my data product with the tag regional, automatically it will look for a column and it will apply it everywhere. And then, yeah, with these tags, you can really have this decentralized approach where the domain, the business can be responsible for looking at what do I care about, what is important for me to hide for certain groups of people or stuff. And centrally, we make sure that we have these policies and that they're managed. Also DQX, so that's a framework by Databricks. It's not a huge framework, but again, it's the same logic where we can have this central location where you can write data quality statements in this case. So you can say, I expect this or I expect that. That's stored in the backend as a generalized check, and then we take it. We make sure it's running every day, and it's checking for these errors, and also making that centrally available in Power BI. So basically, it just looks something like this. You can say, I expect only business units 10 for whatever reason in this data product. So you put that in as a rule. That's something that is happening decentralized. That's happening by the business teams. In the back end, we can see exactly what has been deployed, how often are we checking it, what's the behavior if we find a problem, is it a warning, is it an error, is it something like that. And that's, again, how you can keep track of, are we even doing quality checks in this data product, yes or no, and how are we doing them. And in the meantime, decentralized, you can change all this stuff. So that was the first topic, talking about the teams and how to enable them to do things not directly related to the data. The second one that I think a lot of data engineers run into when you build something like this is that you're consuming data from somewhere. You want to have the contracts set up, so you at least want to have an agreement on this is the stuff we're importing, and this is the schema of the stuff we're importing. and then things change. So that's a fact. So we need to work around that to make sure that we can handle these changes. So one important feature is schema evolution. So that is something I think that deserves more attention. So it allows you basically to run and to accept schema changes. You can, of course, it depends on what type of change it is, whether you can handle it. But if you have good agreements with source systems on how they deal with changes, there's a lot you can do there. And then for consumer side, so if you're consuming a data product, if you're consuming tables, try to make sure that you put something in between. So first of all, don't share files directly. That's one way. But second of all, we call them projections, but most of the time they're just a view where you put something between the actual data and the consumer, which can allow you another degree of freedom in handling with data changes. So to give a more detailed example, in the case of schema evolution, well, the default, of course, is you break all the time, because you're going to say, well, I expected an int, but I got a float. But you can say, well, let's allow for additive columns to just move in. That's one way of looking at it. That's already really powerful, especially if you agree with teams that they just add columns if they change something, and they don't immediately remove a column or rename. And especially renames are tricky because they sound so simple, but they are really a pain if you do them. So that's the additive side. There's also now type widening. So that's where you allow something to move from an int to a float, for example. But of course, vice versa, that's a problem. If you have floating data and you move it to integers, it will just cut off whatever was after the dot, for example. So it doesn't allow for everything, rightly so, but it does allow for some of these things to change and work. Of course, the fourth one is, I added it here from completeness. I wouldn't advise it, but you can allow to override schema, right? To just say, I'll just accept whatever's the new truth. I'll accept as the truth, and I'll just work from there. These do require a lot of thinking. So you really need to think about, okay, if this happens, is it okay that it keeps on working, or is actually the breaking error, is that something I would like? And this is an example basically of this view, where in this case I have an orders table, and by putting a view on top of it, you get this additional degree of freedom to say, okay, let's if there's a column added in the actual table, I can just not add it in the view, and the sources, the consumer will see it as if it's the same data. You can retype things. There's a lot of things you can do in this last bit that will allow you to keep things more stable than they actually are. And that's how you keep the changes of your data inside the data product, while the outside world is seeing stability where it is needed. And the last one is the runtime and delivery decoupling. So what you want is that each data product runs as its own job. So it should fail if it is failing, but it should work if it's working, right? If you have two multiple jobs on the same cluster, that is economically efficient, but it does introduce the risk that one of them is consuming the memory and it breaks the others. So yes, for a few data products it will work, but if you're at scale, you don't want to constantly be looking at clusters and where is the memory consumption really going high or not. So there we really decided to put it with the data product as well, where you can actually configure your own cluster with the data operations itself. So that allows you to scale according to your data needs, and that allows you to change stuff like the runtime versions, the Spark versions, all of that with the code. And that allows different pacing. So once you have time to update your runtimes to the next instance, you can do that. And I think that's a key. Lineage information is really important. So looking at how data is used across all of the systems who are consuming and producing. With Unity, that's available, and that's lineage data. I think nowadays most tools offer it. We've decided to use Purview as a catalog of catalogs. So basically, we're pushing all the data to Purview. We're doing that also for the Fabric, Power BI ecosystem, and for the Click ecosystem. Those are the main ones we're using. And by having that, we have one place where you can see exactly if I take this data product or this source system, then this is the impact across the whole landscape, and we can notify people. We can if something fails, we can see exactly, okay, now this is going to impact all of these dashboards. Let's see what's the criticalness of them. Do we need to rerun ASAP, or can we wait until the next run comes to fix things? That gives you a lot of information. And the last one here, time coupling. I think that's still a challenge for us. I'm very happy to hear if someone here can share some insights after this session with me on how they manage it. We have a mix of schedules, basically. There are multiple ways to trigger your data job, basically. You can have a calendar date, so you just say, okay, let's run every 11 o'clock during the day. You can have table triggers, which basically says if the previous one is updated, then I will update. We have ad hoc runs where actually someone is saying, I need this refreshed for this and this reason, and all of that. And we need to take into account this lineage, right? So if at a certain node someone says, well, let's update this one for one more time, then there's a whole cascading effect that we have. And sometimes that's wished for, sometimes it isn't. So that's really the challenge we're looking at. And one thing we do not want is to create one giant DAG in an Airflow-like application where you just have hundreds of nodes and you need to constantly fine-tune that centrally, because we do want to keep to the decentralized way of working. So that's a challenge. So just to show you an example, this is how a job config looks like. So this is now coupled with the data products itself to make sure that when you deploy, you can also change your settings with the cluster, the number of workers, but also things like the Spark version. Especially the Spark version 1, there are sometimes very nuanced changes there, especially with null treatments, for example. Those are I think famous. You deploy something and then the numbers slightly change because the behavior of the particular treatment, the default, has changed. So that's why we decided to really couple it to the data, because it does make an impact sometimes on the actual results, just updating the cluster version and doing nothing else. So you do need to account for that to make sure that you can keep track of, if we update this version, did it change the data, yes or no? Triggers. This is, I think, what I explained. We're using a mix. We're now looking at the table trigger. So that's a new feature where you say you just consume the data from the table directly if the previous table has updated. But what do you do if you have two tables and one of them updates and the other one doesn't? How long do you wait? Is it critical? Yes or no? There are some questions we still need to solve before we get into a state where we can really have a template for everything. So to wrap up, I think I shared a bit about our journey, what we faced, how we grew from EDW to where we are, and I think some lessons, some key points I hope that some of you can use in their daily work to also improve flexibility and scalability. So it's time. So thanks a lot for your attention.
So we're actually doing a contest which one can make the most applause. So please give you a warm welcome for Geert.
Nice.
Thank you.
Yeah.
Enjoy the mug. Enjoy
Thank
the
you.
coffee.
Thank you.
We're at time, so if there's questions, please feel free to start asking Geert now questions. But we'll close off the session and get lunch.
Yeah. Thanks a lot, guys.
Thanks.
Thanks.